Hello. Okay. Hi, everybody. Are you guys, with a show of hands, here because of the AI user group meetup page, or the joint data science AI hybrid model data page? Okay, none of you are from there. So I would just like to give a quick announcement before we get on to the actual presentation. The AI user group, which happens on the second Friday of every month, and the data science group that happens every first Friday of the month, we've now joined families. So the talks are going to be on the second Friday of the month. And we're gonna have like a mix of topics. So today we have AI, sometimes we might have data science, sometimes we might have a mix of both. So you guys are welcome to come to all of those events. You can look at the meetup page for details on that, and we'll send you updates from time to time about our schedule. But it's great to see you all here. I just wanted to give you guys a quick introduction for our speaker for today. Vlad has been working as an assistant director at the National Center for Supercomputing Applications, say that quickly 5 times, NCSA, and he serves as the director for the Center for Artificial Intelligence Innovation. He holds an adjunct associate professor appointment at the Department of ECE and also a research associate professor position at the Department of Computer Science. Before becoming the director of CAII, he was leading the Innovative Systems Laboratory at NCSA, where they focused on research efforts to investigate and evaluate emerging computer technologies for high-performance computing applications. Dr. Kindertenko received a DSc degree from the University of Antwerp in Belgium in 1997. His research interests include high-performance computing, special-purpose computing architectures, cloud computing, and machine learning systems and applications. Today's talk is going to be about the workflow management with LLMs. The NCSA has been at the forefront of developing tools based on LLMs that serve a multitude of purposes, ranging from chatbots that act as teaching assistants to tools that manage scientific computing workflows. The presentation today will cover an array of LLM-based tools that have been created at NCSA, their diverse applications, and the practical ways in which they've been implemented. Additionally, we will also be looking at the challenges encountered in the process of working with LLMs. So please join me in welcoming Dr. Kindertenko.
Introduction, and thank you for having me here. Let me check the other slides. Yeah, so my name is Vlad Kindertenko. I go by Vlad because nobody can pronounce the Ukrainian name. And as I tell my students, by the end of this presentation, not only you are going to know something about this subject, but you're also going to learn how to understand my Ukrainian accent as well. So I work at the Center for AI Innovation, which is part of NCSA. A few words about me. I've been the director for the center, the co-director, co-founding co-director since the beginning, a few years ago, and for the past 3 years I've been leading this effort. And so I guess just a few words about the center itself. Obviously, at some point, everybody realizes that AI is about to happen in some sense, in some ways. And there were a lot of efforts in different organizations, different communities to try to bootstrap some efforts in sort of advancing the technology and figuring out the ways to use this technology. And the Center for AI Innovation at NCSA was also set up in response to that. our basic sort of pillars were to work with academic research community to take advantage of the developments in the area of AI. We do not necessarily always want to invent new methods, but we definitely want to be able to use the existing methods and apply them in new ways and, to solve new challenges and applications. Another pillar for us is working with students. The students at VOI take a lot of courses in machine learning, in all kinds of technologies related to AI. And they come very prepared academically, but they are always looking for projects to work on. And as a result, they are always looking for opportunities and are eager to apply their knowledge obtained in the classroom. And so we decided that we would be that one place where the students can actually come and work and actually continue to develop their skills and apply their knowledge to solve problems. And as a result, we typically have in our center somewhere between 30 to 40 plus students every semester working on a variety of projects, mostly related to AI, but some of them are related to other things. Of course, we are also, CSA has an industry program, and that program is set up to help US companies to make use of high-performance computing originally, but more recently data science and big data and artificial intelligence as well. And so we are working with companies to help them to use this technology to advance their progress. And in particular, we look at this in partnership with the companies from the point of view that the company has a problem. The faculty, the researchers at UFI might have a solution, and students are willing to implement the solution. And so we are trying to bring these three entities together to work on problems of joint interest. And we're also interested in exploring technologies related to AI and making use of them and also making them available for everybody. So here are a few examples of projects that we've been working for the past few years. So we have kind of a collection of traditional ML deep learning projects where we work with CNNs essentially of some sorts, or models built on the top of CNNs to perform some sort of image analysis, video analysis applications. Some of them are related to processing videos and trying to analyze human behavior, such as fight detection. Some of them are related to processing videos to extract some information about the surrounding environment, like this vehicle classification and tracking project, with the ultimate goal is to use a video camera as a pollution sensor by looking at how much traffic it is and precisely describe what the traffic is and remapping this into pollution and so on. But on the generative AI, we have several projects which mostly related to using large language models in different contexts. And we do have one project where we're also looking at building generative models to sort of perform analysis of MRI images. We have a collaboration with our colleagues from Patman Institute, and we're very much interested in being able to sort of build complex representations of essentially build a foundation model for MRI image analysis. Okay, so large language models. So, my presentation is mostly going to be about what we do with large language models. Just some sort of as an introduction to what it is. Asking the GPT-4 model to explain what it is. The GPT-4 tells me that this is an AI model that is designed to understand and generate human language, which is kind of a pretty high-level interface to anything in computer science. This model is trained on a lot of data and can perform a variety of tasks, which is wonderful because we do want to use it for a variety of different tasks. And these are all language-related tasks. So we want to ask questions and get an answer. We want our model to guide us towards something. We want our model to generate something in a human readable way, maybe even if it's a program, but still human readable. And what's really interesting is these models, all these foundation models are really trained by simply looking how to predict the next word in the sequence. But because of their complexity, because of their size, at the end of the day, they actually are much more capable than that. They are able to generate contextually relevant responses and be useful to many applications. Just a little bit of history. This is this field of large language models kind of has its roots in the early 30s, when people started to think about this field of computational linguistics, even before the computers were invented. The first real example of some sort of NLP-based system was in the 1960s, a machine built at MIT called ELISA that people could converse with natural language, and this was the beginning of the NLP era. The next big milestone was the introduction of RNNs that can handle sequential data, because if you look at most of the perceptron type of networks or convolutional neural networks, they all sort of getting an input and producing one-shot output of that, so just analysis without taking into account any sort of sequence of data or any sort of relations between temporal relation. And so RNNs were the first networks that looked at that, and of course LSTMs that are actually now very widely used in all translation tools. And there are some other more recent developments, but I think the most important things that kind of bring us to LLMs is the introduction of the GPT-2 model by OpenAI just a few years ago. It's a transformer-based model, and everything that sort of followed after that. So LLMs is kind of a subset of an NLP, which sits at the intersection of many other domains. So it uses a lot of tools and techniques from deep learning, because these models are pretty complex, pretty long, and pretty difficult to train. It takes sort of a lot of inspirations and a lot of tools from computer science, general computer science. How do you handle big data? How do you work with large number of files? How do you move the data fast enough? How do you implement kernels which can compute very fast on GPUs and so on? And of course, it takes a lot of inspirations and knowledge from just the human language domain itself. Okay. There are several types of LLMs, so there is kind of a very, very high-level classification of them. So generative LLMs, they are designed to generate human-like text based on some input that they receive. And they are used for things like writing something or creating content and so on. There is a particular flavor of them, or actually a particular way of using these types of networks is through retrieval augmented generation. And so all the tools that we've been working with at CSA are kind of based on this RAG approach. So here, these models combine the data that can be extracted from some knowledge bases, and then they supply this data as an input, this text as an input into generative LLM, and generally an LLM then has more guidance about how to properly answer a given question. And then there are, of course, all kinds of fine-tuning that can happen to these models to make them more specialized, to know something about specific topics or specific areas. There is also this term foundation models. These are, generally speaking, very large models which are capable of doing all kinds of things, and then can be sort of adapted to different downstream tasks. And of course, there are specialized LLMs. So these are, I kind of already had this slide previously. These are some of the topics or some of the research areas that we work at CSA with LLMs. Our flagship platform called UIVC.chat, which we recently also made available for chat.ui.edu. That's an AI-based chatbot platform. There are many applications of it. The original intent was to build teaching assistants using this platform, but we have all kinds of applications now that go beyond that. And then more recent work is on being able to build agentic systems that can generate and execute scientific workflows. Actually, can given a description of what needs to be done, can generate the code and execute this code. And I will try to talk about both of this. So a little bit about the chatbot, the chat platform. So I teach computer engineering courses, and typically I have several hundred students in the course. So we hire a lot of teaching assistants. They help with the work that students do. Students ask a lot of questions. These teaching assistants answer them. But the questions are more or less the same, semester after semester. And we are capturing them actually electronically. We use electronic discussion boards for this and all that. So at some point we thought, why don't we collect all this data, all these questions from previous years and answers. It's already essentially curated data because there are thoughtful questions from students for most parts, and there are also truthful answers from TAs for most parts. And so the original idea was to train a model, a large language model on the data, and then enable a teaching assistant based on that. We very quickly realized that it's not that practical, not that easy. It really takes a lot of efforts to do something like that. You cannot scale it to all courses because it's a challenge to collect that data and challenge to train these models. So instead we built this RAG-based system. So a website that enables instructors to go and upload documents. I upload lecture notes before I go to the lecture. I upload textbook chapters, pieces of CUDA documentation. The class I teach is CUDA programming, so I upload NVIDIA's documentation about this. And then the students can go and ask questions, and they get answers based on those materials which are in the system. The way the system is built around this notion of having several endpoints. So there is one endpoint called new. You go to your student.chat/new, and you get this interface where you can name your project and then can drag and drop few files. We support all kinds of file formats, including video, which can be transcribed or released through model and so on. And then you immediately, in a few minutes, you get a chatbot set up. Once it is set up, there is another endpoint called materials, where you can tweak what to do about this chatbot, what models to use. We currently support OpenAI models and also models running on our own systems, but I'm working towards enabling other models. You can say if it's a public or private chatbot, who has the right to administer it, who has the right to have access to it. You can personalize it, add a picture to it, and add some welcome message and so on. Then the students or the users go to this chat/chat endpoint, and they can just ask questions. So this chatbot is set up for, you see, for a course which I teach this semester, which is applied for our program, and students ask, what is this thing? What is this concept of shared memory? Can you show me how to declare it? And the chatbot is going to use the materials which I uploaded. In this case, it will be my lecture notes as well as NVIDIA documentation. And you'll give the answer, and you'll also give examples and so on. And not only that, it also points where these answers are based on. So at the end of the output produced by the chatbot, you will see links which say, this answer came based on this documentation, and that part of the answer came based on this documentation. So you can always go back to the documentation. So this approach basically helps us to deal with the hallucination problem. It's not to say that it's completely solved, but it is much less an issue than if you just ask this question from a generic GPT-4.1. So we've been extending the functionality of this to include other types of interfaces, in particular multimodal support. So we have a product where we went and scraped a lot of websites which are related to agricultural production, and we call this product Crop Wizard. And so here, a farmer can ask a question about anything related to ag production, including uploading an image of, taken from the fields and asking what's going on here. And the chatbot then is going to analyze this image, and it will tell you, this is, you see this corn leaves and they are damaged by this type of disease, and this is what you need to do about it. So there is another endpoint where the owner of the chatbot, so an instructor, for example, who set up it, can actually see what's going on, how this is used. This is query analysis endpoint. At the moment it's disabled, we are kind of figuring out some issues with, with contracts to use Nomics tools for this, because for a while we were able to use their tool for free, but once the size became above their threshold, and now we have to have some sort of commercial agreement with them to use this tool. But this tool is pretty nice because it gives us semantic clustering of all the questions that we asked, and then the instructor can go and click on any of those dots and get the answer to the question and the answer that the chatbot produces. And it's also possible to download those, and it's possible to download them as a spreadsheet, or it's also possible to download the entire history of that chatbot in the markup format, and so you can actually see how more or less how it looked when the students were asking the questions. We use this as a tool to sort of see what's going on. So on the first day of class, students start to ask questions like, who are you, what can you do for me? But later on, they start to ask more intelligent questions, related to the concepts of the class and so on. And if I look at this tool and I see that there is a new cluster of some questions about some topic, it means that students are having an issue with this, and I can probably address it in my next lecture or something like that. So we also recently added the ability to add external tools. So, if you ask a question like, what is the weather today? The chatbot is not going to be is not going to be able to answer that because it has no notion of today, it has no notion of the place where it's supposed to be happening, has no notion of what that weather is supposed to be. However, with the addition of tools, for example, if the chatbot can actually search for that weather from the weather services, then it can return some sort of a description. Yeah, so today this weather is supposed to be such and such, and then it can embed it into its own answer. And so we enabled, so build this interface where users can basically graphically design what sort of services they want to have. Here's one example. You can ask a question here, which planets will be visible over Seattle on such and such a day. The chatbot is going to say, all right, so you want me to use this tool to answer this, so I'm going to connect to the tool, send this question to the tool in whatever format is configured for this tool. You will get the result, and then I will use this result to generate the answer. So it becomes part of the answer, and the answer is still generative, so the chatbot still is going to rewrite it in its own way, but it will actually have the feedback from that. And the tools can be a variety of them. So here is another example of this crop wizard, where we also have a bug detector tool. So here I upload the picture and I ask, who is this bug? What is it doing to my plants? And the tool then calls another CNN model somewhere there, which is capable of doing segmentation. I don't know if you can see it or not, but there is like a detected boundary for this bug. And also is able to do the classification. So it detects, using another neural network, it detects what kind of bug it is and then goes and generates the answers for this. And it's possible to add an infinite amount of tools. One of our engineers, added the tools that connects to his Gmail account and so on, so he can ask a question, give me a summary of my emails, and the chatbot can go and do that. Yeah, so there is a number of options that we can select. There are some options which are visible to the users. There are some options which are visible to administrators. Administrators can configure this. We are currently supporting OpenAI models, and the GPT-4o Mini is the most popular one. This is the least expensive and perhaps the best performing model out there. We also run in one of the models, Llama 3.170 billion parameters model on CSA's hardware, and we can use that model. We can also run local in-browser LLMs. This will be small LLMs like 8 billion parameter models. They are not particularly that good, but for some applications they're just sufficient. And you also can change the prompt, and there are different ways to use this prompt. In fact, I've seen one of the courses in Geese College been basically building a chatbot per lecture. So each lecture has its own chatbot, and in the context of that lecture, the chatbot actually works like a tutor that helps, for example, to deliver some sort of answer, or some sort of, follow some sort of a process to help students to assimilate a particular concept. We also have an API through which the chatbot can be accessed, so you can create a chatbot for a particular purpose, and then there is an API through which you can actually query it from outside external programs. And that API is something that we are using in the project where we're building an app, mobile app, that enables us to capture. So before I eat something, I take a picture of it, and then later on at the end of the day, you can ask chatbot, so how did I do today in the context of, say, following some diet or something like that. And the chatbot, the platform, the mobile app, will use the data that was collected through these pictures, and then we'll build the query to our chatbot platform to provide an answer, description. And that description, that answer about, how did I do today with regards to this diet, actually will be based on the guidance and then the documents, scientific literature and then advice from dietitians about what I'm supposed to be doing with regards to the diet. And so we are working on that app. We just just a few days ago, we finally were able to put that app in the flight pass for us to test for a lot of users. Well, this semester we have many new courses across the entire university using this for different purposes. Here are some statistics about how it was used in the course which I teach for 2 semesters. I've been using it for a couple of semesters. So overall, students asked something like, what is it, nearly 11,000 questions. Interestingly enough, well, actually, expectedly, the number of questions that the students ask is correlated with when there is a deadline for something, or when there is a midterm exam coming up. And also the time when they ask, and we noticed that a lot of questions are asked between, say, 11 p.m. and 1 a.m. That's the time when there is no teaching assistants available to help them, so the chatbot is something that works for most parts. So we also sort of scraped several websites. And so, for example, one of them is NCSA's Delta supercomputer documentation, and then users can go and ask questions about how to do something on Delta. In this case, they can just simply type in, how do I do this on Delta, or if I get this error message, what do I do about it? And the chatbot is going to generate answers based exactly on that documentation. Here's another example where we work with somebody from or explore this idea with somebody from Carl to build an intellectual cardiology chatbot. And so this chatbot is preloaded with something like 19,000 documents from different journals, actually articles from different journals which all international cardiologists read, and then is able to provide answers to questions based on the data, based on those journal articles. Here's another example. This is something we played with some of the documentation from other companies. For example, this Caterpillar Performance Handbook, which is publicly available. We just uploaded it into this chatbot. This is a very lengthy handbook. I don't know how many hundreds of pages it has. But then you can ask any questions about anything that is described in that performance handbook, and then the chatbot can produce you answers based on that. A little bit about what's going on under the hood. So this is a traditional RAG system. It basically has the ingestion pipeline and the generation pipeline. In the ingestion pipeline, where the user drags and drops a file into this system, then that file immediately is broken into a whole bunch of chunks, small chunks, through the chunker. These chunks are stored somewhere, but they also go through the embedding LLM, and the embeddings for them are computed and also stored in the vector database. And then during the generation, when the user asks a question, the question also is embedded through this, goes into embedding through the embedding LLM, and then a retriever uses similarity scores between the vector embedding for the question and the vector embeddings, all the materials that we ingested, pulls out all of the relevant pieces from the vector database and from the storage, and builds this very complex prompt, which has a user question and it has a lot of materials which were found from in our database, and then asks a larger generating LLM to use all of that information to give the answer to the user question. And then that's what is returned back to the user. So, the traditional RAG, however, we've been working on all kinds of extensions for this, for example, to be much smarter about the retrieval, to guide the system to, try to verify itself if the answer is good enough, and try to regenerate the answer if we feel that it's not good enough, and so on. So there is a lot of sort of research that is going around this, how to improve the performance of this. Besides just working on the user interface and user experience and functionality, we also look into all kinds of issues related how to make the system to be more truthful and produce better answers. On the implementation side, there is a front end and the back end. So where the front end is hosted on Vercel and the back end is hosted on Railways, and then we just use different conventional web development technologies with this. All open source. This has a link to the front end and back end. This is like MIT license, so you can download and do whatever you want with this. We have projects that we are working on sort of removing these third-party dependencies as much as we can, so we can actually have containers which we can deploy in any system, because right now it's running like literally on Vercel and railways hosting. And so we are working on sort of removing that, so we can actually build host the whole system internally somewhere, including the LLM. Because as it turns out, in many cases, users are really not interested in sending data somewhere. They really want to have a very good control of this data. So one of the items that we have to deal here with, and I mentioned it, is that one of the models that perhaps I should not go there. One of the models that we serve is served on our own hardware, and so to enable that, we actually had a project where we built this serving framework, say using RayServe plus VLLM to basically enable a user to go and request any model from Hugging Face, any model which has an interface compatible with OpenAI API. So a user can request any model from Hugging Face. Our framework will go and fetch this model, will then deploy it on one of the computers, on one of the nodes in the HPC cluster at CSA, and would then give the endpoint, and the user then can go and talk to it. And so either directly through the command line interface or programmatically through Python or Java. And so the framework that we built enables to pull in a whole bunch of models, enables to put them on the GPUs, enables to request GPUs when we run out of the available resources, or request new GPUs, enables to remove models if they are not used, and so on. And so this is kind of our way of serving these models on an HPC system where you have a lot of nodes, but you also can serve a lot of users, and with completely different models. Each user can need a different model. We also have some projects related to improving the quality. In particular here, of the responses. In particular here, we look at how we can use sort of feedback loop where AI validates outputs or the responses generated by another AI model, and then critiques them, and then hopefully together with that critique produces better answers. And so the second part is computational workflow. So CSA runs HPC systems, and these HPC systems are built for the purpose of serving broad scientific computing community. One of the ways in which the systems are used is to not just execute a single application, but actually to run a complete suite of applications which are needed to solve a particular problem, and they are referred to as the computational workflows. Suppose you need to get data from some instrument, and then the data has to be preprocess it somehow, and then it has to go into some computational module, and from that module it has to go into some visualization module, and all that. And so, people over the time invented different ways to automate this. Obviously you can have somebody who can just manually follow the steps, but then people invented, or you can write some scripts for this, but people also invented languages which enable to describe these sort of things. And then runtime systems which are able to execute descriptions given in those languages, such as like middle language or Parcel, which is a library in Python. And so what we thought we want to do really is to, instead of somebody writing all these scripts in these languages or writing the code in Parcel, what about if we ask LLM to just write all that code for us? And not just to write the code, but also go and execute it. Because it's already happening on the computer where we are going to be running this workflow. Why don't we ask LLM to actually go and execute it for us? And so that's kind of the idea, original idea for what we wanted to do with these computational workflows, that instead of you doing all the hard work, you just tell what needs to be done, and then there's a bunch of agents that go and try to execute all that. To do this, we have to have a bunch of tools. These tools would be something that an AI agent is able to call. One tool is to do web browsing and finding something there. Another tool is maybe to copy a file. Another tool is run a shell and execute something in that shell. Another tool is to compile something. Another tool is to connect to GitHub and actually work with GitHub repositories. And then there would be all kinds of domain-specific tools. So if you give a software package of some sort, an AI agent might know how to run that package. And so as one of the first examples of this that we built was to use GitHub as the interface to this AI agent. So on the GitHub, you post an issue, so the software developer in his repository posts an issue. That issue could be, I need, can you create with this sort of source code for solving this problem, or can you fix me a bug of some sort, or can you just come up with documentation for the code that I have written? And then the AI agent is going to work on that, and is going to try to generate all the files, or create new scripts, or maybe potentially even go and compile and verify that something works, or look at debugging something, and eventually coming back and filling in this back into the GitHub, the results back into the GitHub in the form of say pull request. That this pull request then can be reviewed by the software developer. The software developer can then decide what to accept, what to modify, or maybe what else to ask the AI agent to fix. And so we started to develop this in the context of one of the projects where we worked with our collaborators from IGB, Integrated Genomics Institute. They were interested in sort of automating some of the processes which were needed to run some of the RNA sequencing steps. And eventually, after some number of trials, the system was able to produce the complete set of scripts and configuration files necessary to run the entire computation, and in a satisfactory manner. Of course, here it only generated these files, but it was not able to execute them. So we also had another project where we said, why don't we try to make the system, I do not necessarily need to know how, but I just need to have the final answer. So let's make a system that actually tries to build this workflow and tries to execute it for us. And so we use this example application, cancer phylogenes application, where some input has to go through some computational steps. And these steps are described originally in the middle workflow description language, and were ported to Parcel at some point. And the computation is like this. You have to load a particular type of files, you have to convert them into something, then you have to execute some computational tools, some applications which perform some sort of analysis, and then the intermediate results stored in the form of files are used by other tools to produce some final results and so on. And so we saw that we could just use LangChain for something like this, and with the LangChain we could sort of parse through the files and kind of come up with what are the steps that need to be carried out, but we were not quite able to execute this in any meaningful way for us. So then we look at that something else. So we look at that OpenAI's function calling API. So basically, with the function calling API, we can provide a description what a particular tool is and what the interface of this tool is. And then the function calling API can actually use this description to generate the proper call to that tool, and use that as a way to execute. So you can call the execution of that particular tool, internally look at the results which are returned by that and decide if those results are acceptable or not, and then call another tool if needed. So the user provides a description. There is an agent that takes that description together with the description of the tools and generates kind of a workflow execution steps that need to be carried out. Because these tools were kind of, for this particular workflow, were implemented as a standalone separate programs, we kind of had to build Python functions, kind of Python function wrappers that would call them, and provide a description. So there is a collection of functions that we gave the description in, that can be then used by the function calling API to understand how exactly to call these tools, how to properly use it. And then it's all just a prompt that we provide a prompt to the system, and the system based on that prompt figures out what functions are needed. So what steps need to be carried out first, and then what functions map into those steps, and or how those steps can be carried out by the specific functions which are provided in the library of descriptions that we gave. And then it goes and tries to execute them step by step and produces outputs. And eventually it just finishes the execution. So I think this is more or less a complete system. So the user provides a query, the user provides a problem statement, and we also give the description of available tools for function calling API. Then OpenAI model generates kind of sequence of function calls that need to be carried out, that they are then carried out by the agent, engine, and once they are carried out, then AI model can continuously review the results and execute them. And this turned out to be quite a workable solution. This actually led us to believe that we can build a system like this. And this is sort of work in progress, but I think this is something that we are kind of getting close to. Given the human language description of what we want to accomplish, we want to have a tool which AI agent that plans how exactly this can be done. So, for example, says, okay, I need this sort of data which can be put into this database, then I need to call these programs to perform these steps, or maybe these functions to perform these steps, and these are the final outcome that needs to happen. Then it gives this plan to the executor, and the executor tries to execute each of these steps separately. And as it goes and tries to execute step by step, it also looks at the outputs, and if the outputs don't make sense, there is a debugger which tries to figure out what's going on. A very typical problem that happens when you try to suppose the executor generated some piece of Python code and tries to execute it, but the libraries or the modules for Python are not installed. So the debugger will then be kicked in to see, okay, there is this module. The error message means that this particular module is missing. I'm going to go and install this module, and then it will try to execute this step. And then there is, of course, a human in the loop somewhere there. If nothing works, let's ask the human. And eventually, this sort of workflow engine is going to be able to, after multiple iterations, multiple trials, to build the workflow and correctly execute. Remains to be seen how much of this is feasible with current technologies, and remains to be seen how much needs to be done to implement this complete vision, but this is something that we are working on. So I think that's actually pretty much it. LLMs kind of revolutionized the field of everything we do with this interface, very simple, easy interface to use, which is natural language. In combination with RAG-based technologies, we can make them to be very precise and very knowledgeable about a particular field without actually retraining the whole model, because it becomes very time-consuming and very expensive. And with RAG, we just build in the knowledge base that is used to help to ground the models in specific domains, specific areas. And we are starting to see more and more of this more interesting, more challenging applications, in particular with AI agents, with building agentic systems where the whole collection of agents works together to kind of try to solve the problem and come up with a solution which is completely machine generated. Of course, this is kind of a work that requires a lot of hands and a lot of smart students to work on, and so here are a lot of students who contributed to this in different ways. We eventually hired some of them to be our NCSA staff, and they continue to work at NCSA on this, on a variety of projects related to this. And so that's it. So any questions?
I was wondering about the application you mentioned that was a RAG system that used journal articles on cardiology.
Yeah.
And I was just wondering if there were many difficulties in kind of translating from the technical language of journals to this. Was this something for the general public to ask questions of?
No, this was actually, we worked on this with a physician. So.
Oh, okay.
However, say that, it's just a matter of asking the chatbot in the proper way. You can tell the chatbot, give me this answer for consumer, in the consumer language, and it will. We also have examples where we try chatbots for other sort of medical conditions or medical things, and you could set the prompt which will guide the chatbot to give the answer in the language understandable by the doctor or in the language understandable by by the patient.
Interesting.
And in fact, we just talked about another project where we want to build some sort of a demo for K to 5 kids. And there we also can ask a chatbot to speak in the language of a 10-year-old or something.
Mm-hmm.
And yeah, it's quite capable of doing it. Oh, another thing is also sort of multi-language support. So, we have a lot of international students in our programs, and I see that sometimes they do ask questions in, say, in Chinese. And we could either program our chatbot or tell the chatbot to answer or not answer in foreign languages. And if you tell not to answer, then it will go and switch to English and will say, we should talk in English. But if you tell the chatbot to, or enable chatbot to answer in foreign languages, it actually is going to use the English-based base of knowledge, meaning all this, the lecture notes are in English and all that, and but the answer will be produced in the native language. So it's kind of amazing too. So it does a translation. Yeah.
So regarding the UI UC chat, right? There were 3 models that the user can choose from: the GPT-O, O Mini, the Llama 72, and Llama 3.18, right? Was there any fine-tuning approach, especially for the Llama models?
No, we just grab one which is available. If you have a fine-tuned model, we can bring it into the system as well. In fact, we are very close to releasing sort of a new set of settings which enables you to specify models from other things. So, from OpenAI right now we can support all the models that OpenAI provides. The owner of the chatbot can specify which ones to be used or not. So just a general GPT-4 model is much more expensive to run than GPT-4 Mini, so we typically disable that. But it's possible to use any of those. We are building an interface where you can also bring in one of the OpenAI models from Azure for their deployment. Also Claude model through several mechanisms through which these models can be brought in. As well as the model that you run on your own hardware, and also any sort of custom model. So we are very close to releasing the support for sort of a much broader variety of models. And then for the models, so instructor or the owner of the chatbot can either supply a chatbot wide key for a given model, and so everybody then can use it without their own keys. Or if the owner does not provide that key, then users can bring their own keys. And then the user can use whichever models he's willing to pay for. Or if nothing else, Llama 70B is free. So running on our hardware it can be used. Yeah.
I know you mentioned that at first they were asking kind of silly questions and then they got better. Is that the main explanation for why the questions count went down in the spring after fall? Or was there
Oh no, that was a different group, different class, and that class was half the size. Of the previous one. So it was much smaller.
So they were actually asking more questions.
Yeah. No, it's a different, it's a 1 semester long course. So in that semester we had over 300 students, and in the second semester we had 120 students. But so this semester, after I introduced the chatbot for the class of something like 380 students, in the first 2 days they asked about 700 questions, but most of them were silly questions. So, yeah.
One more question. In the rack system, so eventually it retrieves information from the vectors, right? Is it only a top K retrieval, or is there any?
Yeah, it's a top K retrieval at the moment, but the K is pretty large. We are pulling in at least 120 chunks of relevant text. We do have a project where we want to build a much smarter retrieval, because the quality of the answer is very heavily dependent on the quality of retrieval. So our idea is that, when you ask a question, the question itself may not be too specific enough to retrieve the right types of data. So we want to, rephrase this question, try to add some additional knowledge to that question, maybe some sort of a taxonomy of related terms or something like that, so that we can get a much richer question itself. And then in the retrieval mode, we also want to build something that not only pulls out, those top K chunks, but also starts to look at those chunks and says, okay, this chunk seems to be interesting. Can I get the next chunk in the text? Because maybe that next chunk was not retrieved. It was not part of those top K results, but maybe it still has some valuable knowledge. just like a person reads, right? When you read a paper, you look at some part of it and you skip to the next part, and maybe you come back. So we want to sort of build a logic like this into retrieval as well, so that we can get a much richer, much better retrieval results. But that generally is pretty difficult to come up with a good enough retrieval for this.
In the beginning of your presentation, there was a list of your projects, yes? And are there any projects which were done in collaboration with other universities, maybe, or all of this project was done with NCSA Center?
Oh yeah, so we are in the NCSA, we are part of NCSA, so all of these projects are originated from within NCSA. We do have several projects where we work with other universities. One of them is we are building a system called Diamond, which is in collaboration with several universities actually. Right now, if you want to train a model on an HPC system, it's a lot of work. You have to set up a code base, you have to get the data, you have to perhaps do something with this data, you have to know how to tune this model, especially if you want to do a distributed deep learning and it's complex. So we are building a system where a user can just go and say, here's my model, maybe from Hugging Face or something like that, or Model Zoom. Here is my data from some other place, and here is the computer I have access to. And the system will tie all this together, will submit the job to the system and will train it there. So we have this collaboration with several universities. And then we also have another collaboration we are trying to build with several universities, several HPC centers, where we are trying to build a system for providing user support. So right now, if you have a problem with Delta system, for example, you submit an email to help@NCSA and describe your problem and all that. That problem, that request is looked at by a human. The human then decides, what to do about it, provides you with a response. We want to put an AI in between. So AI will look at this, will try to see if there are similar questions in the past, can try to answer this question right away if it knows how to maybe consult with a human. If it doesn't, and then provide much faster sort of interface to this. That's done in collaboration with several other HPC centers like NCSA, and for those we do want to have, potentially even fine-tune some models, smaller models on their queries of questions, because system that we have is not the same as system somebody else has, and the problems they see are not the same that we see. So so we have several of this, and some of these projects we also have collaborations with companies where we are trying to deliver some sort of products for them for their specific purposes as well. Yeah.
Are GraphRag going to be considered in your future integration project?
I'm sorry, what is considered?
Are GraphRag going to be considered in your future integration system?
I'm sorry, I don't.
GraphRag.
Oh, GraphRag. So we do have one project where we think we need to build a graph representation to be able to, grasp the concept in general and then find relations which are much harder to see through just RAG itself. So we don't have that right now implemented, but we do have a project where we think this is going to be the solution that we have to implement.
I want to ask how it's checked out to make sure that your answer is correct to the student question?
So right now in our default system, we fully rely on RAG to give the answer based on some sort of knowledge base. So that is ground with that sort of materials. And in most cases, the chatbot is quite capable of doing that. However, saying that, in this spring of this year, in one of my course, one of the students did file a grade request saying that, this is the answer that the chatbot gave me. I submitted it in the answer to the problem, homework problem, and it was not correct. Why is that? Well, the answer for that is read our disclaimer. It's the answer to that. But the thing is, there is no guarantee that it is producing absolutely correct answers. If the answer is conceptual, it probably will give a very good explanation. If the answer is some sort of numeric, there is a good chance it doesn't have all the assumptions or does not understand all the assumptions and will not produce a very good answer. So that problem continues to exist. I think with RAG we sort of improved the quality of answers, but we didn't completely solve the problem.
On that note, do you have any sort of like introduction to the students, like
Oh, yeah.
to tell them like how to use it well?
Yeah. I think in the very first lecture I talk about how to not to use it, you know, and because what we, we talk about this. In one of the later lectures I also give examples of, you know, good examples of how to use it and what it is practical for. You know, there is no way for us to prohibit students from using general purpose GPT, right? They can just don't do it. But if we do it for the course, based on the course specific materials, they're going to get a better quality answers. And hopefully they will use that as a tool to learn. So we really emphasize that, you know, this is just a tool that you can use to learn. Don't use it to cheat. Use it to learn something that you will benefit from. And we also changed the structure of the course to reflect it as well. So that, you know, if you submit all of your homework assignments, solved by the chatbot, there are other ways in which you will fail the course. Yeah.
How do you handle the data security with respect to LLMs?
Yeah.
Because in my previous employer, we were trying to do LLMs, but there was some IP data which shouldn't be shared to.
Yeah, so this is very, you know, very big concern. So far, you know, we provide the conventional security measures. So you know, if you set up your chatbot to be private, then you have to log into it and all that. We use OpenAI API, use GPT models over API, and that has a user agreement which says that the company does not look at that things. They don't use it for model training or that. But at least that's what they tell us, right? You know, if you really have an issue with this, you can run it on our model, on our Llama model, run it on our own hardware, or you can run it somewhere else on your own hardware as well. But I think so. But the next step towards this, we are trying to engineer our systems so it can be deployed on the intranet, so you don't have to connect to internet at all. On your corporate network, you can deploy it on your own hardware, and then it's all completely under your control. So it's a work in progress. We don't have that solution yet. Yeah, that's the answer.
So, if a department, say, wanted to set up a IRB compliant instance, right? What would you recommend for them to do? Go talk to NCSA or?
So right now, chat.illinois.edu platform is kind of available to any faculty or anybody on campus. So they can just go ahead and set up it for their own purposes. We do not support, so you know, if this is some sort of a student data or student records or something that has something to do with student records, we don't really, our platform is not designed for that. We don't provide all of those security measures in place for it. So don't do it for that. Don't use it for that purpose. We've seen examples where you know, somebody set up, somebody pulled in all the student advising documentation and made it available to students. But you know, as long as students don't have to log into the system and don't have to tell anything about them, and the answers are based on non-personalized information, then that's okay. You don't even have to have an IRB approval. IRB approval is needed if you want to do something with this data outside of the, you know, just providing the services. But I think, you know, so we do have a project where we're trying to explore sort of other educational uses for this, and we want to publish a paper about that. For that, we need to have an IRB approval. Okay. I don't know, I think I've done this is all time, right? Okay, great. Thank you very much.
Hi, good afternoon, everyone. I'm Cynthia Fallon. I'm the Associate Director here at Enterprise Works. Just bringing another very informative workshop to you. Thank you so much for your content today. I want to make you all aware of an excellent opportunity becoming available at the end of October. That is another cohort of NSF I-Core. And it seems like there's a lot of potential in the group here today. So there are some flyers on the table here. The applications, you've got plenty of time to apply. How many are familiar with NSF I-Core? Show of hands? Really? 1.5? Wow, okay. I'll give you a little primer. NSF I-Corps, National Science Foundation. I-Corps, we call it Boot Camp for Entrepreneurs. So if any of you are thinking about embarking into the startup world, this is a great way to do it with a little bit of funding from NSF I-Corps. It can put you on the path towards undiluted investment of up to $200,000 or more. So I would, if you're thinking at all about becoming an entrepreneur, would consider seriously applying for this program. Again, it takes place here in Enterprise Works. It begins at the end of October, and it runs on a bi-weekly basis. So there are 4 cohorts that take place here in the building, and then there's homework to do in between. It's a great program, and I think there are a couple of people in the building here who have taken part of, or a couple people in the audience who have actually taken part in I-Corps. So there are people that are familiar with it. Anyway, I'm pitch hitting for my friend Marissa Sierra from the Technology Entrepreneur Center. There's a lot more information about it on their website, but there are some flyers here on the table if you'd like to grab one. Thank you again.